video, I will show you the pre-production circuit board that I put together using off-the-shelf components that I purchased at the local Radio Shack. And I'm going to give you a little tour on the differences that this circuit board has compared to the other one on the breadboard. And then we're actually going to hook it up to the car battery and to the actual heating element that will be inside the Pitot tube. And I will check to see what temperatures we get out of the heating element. Hopefully we'll be able to control it as we please, but that remains to be seen. So I'm going to turn the camera around and show you a little bit about what I came up with. It's not, this is just a pre-production, so it's not a actual etched circuit board. It's just something to put all the little elements on, and there's wires all over the place underneath it. I'll show you. It's not pretty, but it should work. Here we go. Alright, this is a circuit board. Let's make sure it's in focus. And as you can see, one of the biggest differences that you might notice is this heat dissipator, and it's connected to the brain of the whole circuit board. Reason being is once you start drawing 3 amps, this element here might get kind of hot, and I want to make sure it doesn't burn up. The other thing, well, obviously the little red LED that comes from the circuit board. Unfortunately, I burned one up, and that was the only one I had. But the other thing you'll notice is that there's no potentiometer anymore. What I did, ended up substituting resistors for it. I made 3 individual circuits. Every one of these circuits represent obviously a different ohm value. If you remember last videos in that voltage regulator test spreadsheet that I had, depending on the value of the resistance in this circuit, we get a different output voltage-wise on this side, which is the side that goes to the heating element. So I designed 3 separate individual circuits that will be selectable. Let me pan out a little bit. That will be selectable by connecting this cable, or any one of those, to the green cable. The best way to do it would have been to use a 3-way switch, but yesterday when I went to the store there was no such thing to be had, so we're kind of stuck doing it this way. I'll be using this jumper cable to make the connection. Nothing fancy, of course, but it should work just fine. And we'll hook up the heating element. Heating element is in its usual enclosure there. We'll hook it up to the output, and using our digital thermometer, we'll measure what kind of temperatures we get on the heating element. And if this all works all right, we should be able to select 3 different levels of voltage, get 3 different levels of temperature at the heating element. And without wasting any more time, I'll go get the jumper cable, set these up, and we'll run the experiment.
Please hang up and try again.
Unfortunately, I must have deleted the part of the video where I hook up the car battery to the circuit board and the circuit board to the heating element. Also in that part of the video, I was recording the initial temperatures of the Pitot heat element when it goes from about 60 degrees room temperature and it starts warming up. So unfortunately that one's gone. We're going to pick up the video from the next point, and that's where I come back 5 minutes later and check what the temperature of the heating element is. That is with circuit number 1 connected. Then we'll move on to circuit 2 and circuit 3. Alright, it's been 5 minutes. Looks like it is nice and warm. It's actually warm enough as you can touch it. The temperature has stabilized, and I'm going to see exactly how hot this thing is getting. You can see about 100, if I can aim it right, 140, 148. Alright, let's call it 150 degrees to make it nice and round. There you go, 150. So 150 degrees, that's using 3.3 volts at the entrance. I'm sorry, using 3.3 volts out. That is determined by the resistors that I picked and by me selecting that circuit. Next we're going to try circuit number 2, which has a high resistor, and this should give us 4.5 volts on the output to the Pitot tube element. So you're going to go ahead and switch the leads from circuit number 1 to circuit number 2. There you go. Circuit number 2 is connected now. We will go back to measuring the Pitot heating element temperature, and let's see if it starts going up, as it should. And then once you're comfortable with that, we're going to let it sit another 5 minutes and come back and check the temperature again. As you can see, it looks like his temperature is climbing. We're 55, 57 now. So we're going to leave it for 5 more minutes here, and we'll come back and see how hot this thing really is getting using 4.5 volts. This heating element has been running for 5 minutes on 4.5 volts. We're going to check the temperature, see if it's stabilized. See if I can aim it just right. Looks like about 216 degrees temperature. That's pretty warm. That's a nice volume. You can feel the heat just fine. I'll turn around and check and see how well our heat dissipator here is working. Looks like it is running at about 110 degrees, so that's not bad at all. Next step, we're going to connect it to the third circuit, which is the 5.5 volt circuit. That should run things even warmer, and shift the focus to the heating element and see if it is actually increasing, and then we'll lay it around for 5 minutes and come back and check the temperature once again. Okay, it looks like the temperature is going up. We're going to pause this video, come back 5 minutes from now, and see how things are. Alright, it's been 5 more minutes. This heating element has been running on 5.5 volts, and it's warm enough that you can start smelling it in the air now. Something's cooking. So we're going to check it. We're giving it plenty of time to stabilize, and let's see what we have here. I'm going to move my wrist here, trying to get the highest temperature I can by aiming the infrared sensor. Okay, so we got 272, 273. I'm slowly moving my thermometer up, and there we go, start losing it over on the top side. So I'm going to move back down and back for the center of the element. And it looks like about 270, let's call it 274. Yeah, about 274 degrees. So 274 degrees is the hottest this element gets using 5.5 volts at the output of the circuit. We're still feeding the 12 volts straight from the car battery over there, and I'm pretty satisfied. We have been able to control the temperature of the heating element at will by utilizing this circuit board that I made. The only last one thing I wanted to check was the temperature on this heating fins. It feels rather warm right now, and just want to check and make sure it doesn't get too hot, because that's probably going to be inside some sort of a box. So 141 degrees, that's not bad at all, considering how many amps are going through the circuit. And heck, I couldn't be more pleased about the way things turned out. Okay, well, that seems to have worked quite well. I'm really excited about the way things have been working out. We started out with the idea of a Pitot tube that was heated. I was able to machine it in my lathe at my mill. Came out rather nice. We used a heating element from straight off a Cessna aircraft, and found out that it was getting too hot, about 700 degrees, unacceptable in the nose of a composite airplane. We came up with a few ideas on how to step that temperature down, and finally produced a circuit board that will allow us to control the temperature of the Pitot tube as we like. So I'm very excited about it. The next step will be to turn this into an actual circuit board. I will find out how to hatch it myself. Done it when I was in my teens, but that was quite a long time ago. So I'll have to bone up on that a little bit, try and figure out exactly how they do it nowadays, and then replicate the circuit, test it again, obviously, and find an enclosure for the whole system. And then I will ship it on to Mike for him to do some flight testing with. Obviously, this plane is not quite ready yet, so that might take a little more time. But as things are right now, I'm completely happy about our development, and ready to move on to the next thing. We're gonna have to finish up the tube that I started for Wade. I don't know if you remember, but I'm making a retractable Pitot tube for Wade. We used a few ideas on how to do that, and I think we're settling on one that is going to work real well. His Pitot tube will be heated as well using the same circuit, and mine will be heated as well using the same circuit. I have not quite decided what the proper voltage to use is going to be. We might have a high and low setting, but I want to test this heating element enclosed inside a Pitot tube, just to make sure, that the actual temperature that the heating element puts out is what we actually get on the surface of the Pitot tube. But that's all details, a little more research and development to do, and I think we're on a good path. It should be getting done pretty soon with this thing. Thank you for watching. I hope you enjoyed the development of this heated Pitot tube. Thank you.